let's talk about the alkenes. The alkenes are a group of organic compounds having the general molecular formula CnH2n, and they are simply compounds that possesses the double carbon to carbon bond. They have the double bond. So this is it. Once I am able to establish this formula, it means I can write the formula for every one member of this family. For example, don't forget CnH2n is the formula where n is greater than or equal to 2. So in this case, n begins with a 2. So how do we start? How do we begin writing the members of this family? So we have for n equals 2. When we substitute 2 in here, we are going to get C2 because n is 2. 2 in here, that is 2 times 2, which makes 4. So we have C2H4. 2 carbon, 4 hydrogen. So that makes something like this. Remember, the alkenes are basically double bonds. They possess a carbon to carbon double bond. The alkanes previously stated they possess a carbon to carbon single bond. That is what they are known for. That is their property. Now, in this case, 2 carbon atoms bonded by a double bond having 4 hydrogen. So for the alkanes, we simply write them like this. We have hydrogen, now 4 corners for hydrogen. So this is the structure for the alkenes, which is basically ethene. The first member is called ethene. So this is the structure for ethene, having molecular formula C2H4. Structure written in this manner. When n is 3, when n equals 3, substituting 3 here, we have C3. Putting 3 here, 2 times 3 gives us a 6. So we have C3H6. Looking at this, it simply means we are going to have 1, 2, 3 carbon atom, of which one is attached to the double bond. So this one will have 1, 2, 3 carbon atom. This possesses 1 here, 1 here, and 1 here. So that makes 1, 2, 3, 4, 5, and 6. This is how we draw C3H6, of which the name is called propene. Remember, they take after the E, family name, the E's. They are simply double bonds. Now, the double bond is simply attached here, meaning there is a decrease in the number of hydrogen compared to the alkanes, of which we have 1 and 1 here, making each of these carbon to be bonded by a hydrogen. But in this case, we simply have just H in one part, while this is attached to a carbon to carbon single bond. So for that reason, this carbon is alone. We simply bond by 3 hydrogen, 1, 2, 3, making 1, 2, 3, 4, 5, 6. This is how to draw the compound propene. And then the likes keeps going on and on. For example, when n equals 5, we are going to have, substituting n to be 5 here, we have C5, 5 here, that makes 2 times 5, 10, C5H10. The name of this compound is pentane, and it takes after the ene family because it is belonging to the Alkene series. Now C5H10, how do we draw this? We have 1, 2, 3. I decide to put my double bond here. 4, and I decide to put it here. 5. This is where the double bond is located. Now, it is bonded by 10 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So each of these hydrogen atoms is placed 7, 8, 9, and 10. These are simple because of the double bond. Now the key is this. We can keep writing on and on for every member. Now take note, this could also be called pent1 in. Pent1 in because the bond where we have the in, the family, what represents the homologous series. The in is at the first carbon atom, in this case, this one. So one, I simply have the double bond. So it could also be called pent1 in, depending on where the double bond is situated. So it is at the first carbon atom, so we can say pent1 in. If, for example, the double bond is placed at this point, it means I will have to name the compound by counting 1, 2, which makes pent2 in. But we will come to all of that when we name these compounds. Now, let us understand how to utilize the formula in drawing the structures. A good understanding of the formula will help you to draw the structures of these compounds. I'm sure we got value from this video. If you are new to this channel, please do well to subscribe, like my videos, and share for more persons to see. See you for more explanations on naming of compounds. Bye for now.